Hi everyone, welcome to our channel. Today let us discuss about column chromatography. Introduction. Chromatography. Chromatography is a separative technique whereby the components of a mixture may be separated by allowing the sample to be transported through a packed bed of material by a fluid mobile phase. If the fluid mobile phase uses a gas, that is carrier gas, the technique is known as gas chromatography. If it is uses liquid, then the technique is known as liquid chromatography. Each technique may be further subdivided according to the nature of stationary phase. Like, if the nature of mobile phase is gas and the nature of stationary phase is solid, then it is known as gas solid chromatography. If the nature of mobile phase is gas and the nature of stationary phase is liquid, then it is known as gas liquid chromatography. And if the nature of mobile phase is liquid and the nature of stationary phase is solid, then it is known as liquid solid chromatography. And if the nature of mobile phase is liquid and the nature of stationary phase is also liquid, then it is known as liquid liquid chromatography. Column chromatography. Column chromatography is a chromatographic technique in which the separation of components of mixture is achieved by using columns packed with stationary phase, where over the stationary phase the mobile phase is continuously flowing over it. It was developed by American chemist, that is T.D. Day, in 1900. When a column of stationary phase is used, the technique is known as column chromatography. Based on the nature of stationary phase, it is divided into two types. It is, if the stationary phase is solid, then it is called as column absorption chromatography. And the stationary phase is liquid, then it is called as column partition chromatography. It is a schematic diagram of typical modern column chromatography, which contains electing solvent, glass beads, stationary phase, separated components, fingered glass disc. Next is principle. Uh, a solid stationary phase and a liquid mobile phase is used, and the main principle involved in this column chromatography is absorption. When a mixture of components dissolved in mobile phase is introduced into column, the individual components moves with different rates depending upon their relative affinities. If the compound have less affinities towards the stationary phase, then that compound moves faster and hence it is elected out in the column. It is separated out in the column. If the compound have greater affinities towards the stationary phase, it will move down the column slower and it is separated later. Diagram we can see that glass wool or cotton is down, then stationary phase is introduced, that is absorbent, to the column, then sample is introduced which contain X plus Y. After sample introduction, the mobile phase is introduced to the column. After mobile phase introduction, the sample which contain X plus Y start to separate like X zone or Y zone. Then upon continuously flowing of mobile phase, the sample gets separated like X zone and Y zone, and separate bands are formed. Based on their relative affinities, the X plus Y zone is separated. Which have less affinities is separated first, and which have more affinities towards the stationary phase is separated later. This is the one of the diagram of column chromatography, which contain electing solvent added, which solvent is added upon the layer, upon the column. Then sample, that is mobile phase, and solid material, that is stationary phase, and glass wool are plug down the column. These are the some of the examples and diagrams of column chromatography. Next is apparatus and instrumentation. Column apparatus. A simple straight glass tube tapered at the bottom and often fitted with the top is still commonly used in this column chromatography. The tube is about 20 to 30 centimeter long and 2 to 3 centimeter in diameter. This may hold 50 to 100 gram of absorbent and may retain several grams of absorbate. The absorbent is supported on a plug of cotton or glass wool may be used. These are the equipments of column chromatography. A is simple version of column chromatography which contain motile flask with eluent, glass columns, column packing, glass wool, element of detector or fraction collector. And B is sophisticated version of column chromatography which contain eluent reservoir, pump, adjustable plunger, nylon disc, adjustable plunger, glass wool or detector or fraction collector. Stationary phase, also called as absorbents. Particle size and geometry. The particles should have uniform size distribution and have spherical in shape. It should have mechanical stability, that is, it should have high mechanical stability. It should be inert and should not react with the solute or other components. It should insoluble in the solvents or mobile phase used. It should be colorless to facilitate observation of zones and recovery of compounds. It should allow free flow of mobile phase. Types of observant used are based upon their observed activity, they can be classified as weak, medium, and strong observant. The weak observant contains sucrose, starch, inulin, talc. The medium observant contains calcium carbonate, phosphate, magnesium carbonate, magnesium oxide. And the strong observant includes activated magnesium silicate, activated alumina, activated charcoal, activated magnesia. This mobile phase. The mobile phase is very important and they serve several functions. They act as solvent, developer and as a eluent. The function of a mobile phase are to introduce the mixture into column, act as solvent, to develop the zones for suppression, act as developing agent, to remove pure component of a column, act as eluent. Different mobile phases used are based on increasing order of their polarity or elevation strength, like petroleum ether, carbon tetrachloride, cyclohexane, carbon disulfide, ether, acetone, benzene, toluene, ester, chloroform, alcohol, water, pyridine, organic acid like acetic acid. These are used based on their polarity or elevation strength. Next is column characteristics. The material of the column is mostly good quality neutral glass since it should not be affected by solvents, acid or alkalis. An ordinary burette can also be used for column separation. The column dimensions are very important for effective column separation. The length diameter ratio ranges from 10 is to 1 to 30 is to 1. For more efficiency, the length diameter can be 100 is to 1. The length of the column depends upon affinity of compounds towards the absorbent used, number of components to be separated, types of absorbent used, quantity of samples. Next is preparation of the columns. The bottom portion of the column is packed with cotton wool or glass wool or may contain absorbate pad above which the column of absorbent is packed. A Wattman filter paper disc can also be used for this. After packing the column with the absorbent, a similar paper disc is kept on the top so that the absorbent is not distributed during the introduction of our mobile phase. Means disturbance in the layer of absorbent will not lead to irregular bands in separation. Dry method packing or wet method packing. These are the two types of preparation of column chromatography. Dry method packing contains at first the stationary phase, example powder silica is filled first, and then the only the solvent solution that acts as mobile phase is allowed to flow through the column. And the wet method packing includes in this procedure stationary phase and solvent mixed together that lead to the formation of slurry is packed in the column. Next is introduction of sample. The sample, which is usually a mixture of components, is dissolved in minimum quantity of mobile phase used for preparing the column or a solvent of minimum polarity. The entire sample is introduced into the column at once and gets observed on the top portion of the column. From this zone, the individual sample can be separated by the process known as elevation. After the introduction of the sample by elevation technique, the individual components are separated out from the column. The two techniques used in development technique are isocratic elevation technique, gradient elevation technique. ISO means same or similar. In this elevation technique, the sample solvent composition or solvent of same polarity is used throughout the process of separation. Example, petroleum, ether and benzene, that is 1 is to 1 ratio only. Then next is gradient elevation technique. Gradient means gradually. In this elevation technique, solvents of gradually increasing polarity or increasing elevation strength are used. During the process of separation, initially low polar solvent is used, followed by gradually increasing the polarity to a polar solvent. Examples includes initially benzene, then chloroform, then ethyl acetate, then to methanol. Detection of components. The detection of colored components can done visually. Different colored bands are seen moving down columns which can be collected separately. The next is recovery of components. Earlier, recovery of components were done by cutting the column to different distinct zones. Later, extraction of the column into zones were done by using plunger. The best technique is to recover the components by a process called elution. The components are called eluent, the solvent called as eluent, and the process of removing component from the column is known as elution. Thank you. Please subscribe our channel, like and share. Thank you once again.